So now I'll get into GDB. So this is just a quick GDB primer. GDB is the GNU debugger for debugging the programs, and I found it really useful. There's also a command line tool that's available on your host, which is DDD, but I wasn't able to configure it to run cross-platform. So the way you use GDB is you say GDB followed by the binary, and generally when you compile the code, you set a -G GDB option, so it actually loads debugging symbols into your executable. So when you debug, you can actually put breakpoints at function names, using function names and things like that. And there's also a way to pass an initial set of commands. So every time you debug, let's say you always want to see what's in registers R0 through R12 or whatever, for any reason. So you can pass this initial commands file using the -X option, and it will run those set of instructions for you at the beginning of when you start GDB with the binary. And for help, you can always type help. And to actually start, what GDB binary does is it just loads the program and prepares it for debugging, but when you actually say run is when it starts running. And if you have any command line arguments that you want to pass, you just pass it to the run command. So you say run followed by argv. So this is a possible set of initial commands that you guys can create in your emulator. And this just prints 10 instructions ahead of where it's executing, and it prints like R0 through R11, the stack pointer, and the CPSR. So you guys can use that. And to put the breakpoints in GDB, you just say B for breakpoint followed by the function name. And if you want to break at a specific address, you put an asterisk before you specify the address. You can specify it in hex. And then you also have branch with file name colon line number if you actually have multiple files. And then breakpoint with a line number, so it will accept the line number. If you actually type list, it will list the program out for you and the line number, and you can choose the line number. Then there is also info B, will show you what breakpoints you've set. And to remove the breakpoint, you have to go back to using the same notation as here, and you can say clear followed by the function name, or clear followed by the instruction address using an asterisk, and so on and so forth. So if you want to remove a breakpoint, you first do info B, see where the breakpoints are, and then clear them. Similarly, to display or look at memory contents, you use the X or examine command. And so the examine command actually takes a format string. So if I want to look at a particular memory location, and I want to look at 32 words in hex, this is how I would do it. So this says look at 32 count in hexadecimal, print the values in hexadecimal, and print them a word at a time. And I'll show you more examples of this in a little bit. Disassemble is very useful if you have shared libraries or libraries in memory, and you want to look at the assembly code for those functions. You can say disass and followed by the function name, and it'll disassemble your function and show you the assembly code. Again, to see breakpoints, you do info breakpoints. Similarly, you can also look at registers. So if you want to print out all the registers and look at the values, you say info reg. It'll print out all the registers. And if you want to step one line at a time, you say step I or SI for short. And if you want to continue till the next breakpoint, you just say C. BT will print a backtrace of all the methods that you've called through. So this is like a brief intro to GDB. You guys should be familiar with it. Do you have any questions?
I'm sorry, just I missed it. When you want to break on a specific instruction address, that's the asterisk just indicates
it's a memory location.
Okay.
And you'll actually use it a lot for your hijack lab. This is the bomb lab. So this is actually a binary that's been given to you in project / I think it's bomb lab. So, and your job is to defuse the bomb. So if you haven't heard of this before, all it is you have to provide each phase with a specific input to defuse that phase. And to figure out what that input has to be, you have to debug, essentially, and figure out what is the correct input to defuse the phase. So the first thing I would recommend is actually to put a breakpoint on explode bomb, because that's what gets called if you input the wrong code for each phase. And so it will prevent it from exploding. So Dr. Evil has prepared this bomb, which is binary, and job is to disable the bomb. And so the way you would start debugging the bomb is you just say gdb-x with your initial commands file, and followed by the bomb. So you can also put a breakpoint on explode bomb, and to disassemble the first phase, you would say disassemble phase under bar 1. So each of the phases is actually labeled pretty easily, so it has all the debugging symbols in there. So you can say phase under bar 1, phase under bar 2. And info reg is also useful to see all the registers, but if you have that initial commands file, it will keep outputting 10 instructions at a time every time you step. And if you want to scroll up and down inside that terminal screen, you can use shift page up, shift page down to scroll. Sometimes it's hard. Oh, yes. So there are 2 bombs for your fun and pleasure. So you can choose whichever one you want and have at it. So they've been randomized. So there are different phases that stand for different pieces of assembly. So they have different strings.
If we look at the C code, will it give us the answer?
No. Actually, the C code, all it does is it calls the phases. So.
Okay.
Yeah. I don't think you'll have the phase code, which is what's needed. And you actually also have tab completion in GDB. So if you just type explode through tab, it'll finish the function for you. The other thing you could do is put all your answers to each phase in a text file and then feed it in when you say run. You can do a less than and do a redirect cat. Or you can actually say run with the file name. Sorry. So I just want to highlight to you guys the ARM instruction set manual that's also included in your references on the VM. So it's a great resource. So if you go look in ARM references, so it has the ARM architecture manual. So let's say I want to find TBB. You do a find. Eventually you get to this table branch. Click on this.
Let's do 1 byte. That's what we're looking for. Where do I start looking at desktop documents?
Oh, sorry. So if you go into desktop ARM references, there's a folder.
We don't have any control.
And the Cortex A9 technical reference is a slightly older version of the same manual. That keeps changing. And this folder also has your ATPCS, so the ARM thumb procedure call standard document. So this sort of goes through all the different register notations, also sort of the least significant bit being set for some mode for the address. So section 5.1 is the place where it actually says use the branch and exchange instruction, branch to a destination, and simultaneously change instruction set to that specified by the least significant bit of the destination address. So basically that means your address, you specify it by setting the least significant bit for thumb, or leave it at 0 for ARM. When you use DXLR, it changes to the appropriate set. And this is actually used when you're doing error working, where you have combined ARM and thumb. Right now, everything that you're using is all in thumb mode. Another way to format your examine output is actually, so when you say 32XW, what that means is show me 32 hexadecimal words starting at this memory location. Similarly, you can say /5S, and it would show you 5 strings at that memory location. Or you can also say /10I to show 10 instructions. So if you're looking at instruction memory and you want to see the opcodes or whatever, or decode the opcodes at a particular memory location, the /10I is pretty useful. Actually, we had this here, so we're using it with display, but part of the initial commands font that you can put in to a file, and it'll always display 10 instructions for you. I was hoping Raspberry Pi would have come out by the time I taught this class, and I could do it on bare metal. So
Oh.
it would have been $25 a pop. Nice. But I encourage you guys to go ahead and buy those Raspberry Pis. Try these out.
Made by whom?
So Raspberry Pi, there's a foundation called Raspberry Pi Foundation.
Oh.
So they sell these, I believe those are Cortex profile also. But they're just the entire system on chip. They have USB, HDMI, all of this built in on the board.
Mm.
There are some other boards that are available that you can use also, like Panda board and Beagle board. You get those for about 180 to 200 bucks with all the peripherals and everything. So they have like multiple USB ports, HDMI. They actually come with the Panda board, for example. I just bought it recently. Has 2 Cortex A9. It's a dual core Cortex A9, and it has 2 Cortex M3 processors also embedded on the same board. And so it's using all the peripherals essentially to do video processing and things like that for HDMI. It also has USB ports and an Ethernet port. So you can run a server on one of these things if you wanted to. It's really useful. So a lot of the questions I got in my other class were related to more the microcontroller side of ARM, which is sort of different from this Cortex A profile. So this is the actual website for Linaro. And this has a bunch of companies that are down here at the bottom, like ARM, Freescale, IBM, Samsung. They're trying to encourage open source development on these ARM platforms. So if you go to their download section, you can actually get all the Ubuntu images, which is what I'm running on the emulator. You can also get Android to run, and these are all the boards that are available. You can even run Nano Linux. They have a developer image also if you want. So they also have all the tool chains like GCC and stuff for compiling from ARM. So the other websites that are useful is actually So Mentor Embedded has a website that sells, they actually have a light edition which gives you cross-compiler tools called Code Sorcery. So if you wanted to cross-compile for the emulator, you could use these cross-compilers. You can download the light edition, and when you use a tool set, you use the GNU Linux EABI toolchain for cross-compiling for the emulator. That's the other ones. This is the actual Panda board that you can buy. For some bare metal fun.